So what exactly is design intent? Well, it's designing parts so that they can be easily changed while maintaining the intent, so the function of the part, while changing sizes and keeping things aligned in the ways that they should be. The way we do this by using geometric constraints, so midpoint, equals, horizontal, vertical, collinear, things like that. When we do a model with good design intent, it also makes it easier and faster to create it, because now instead of having to dimension things twice, we tell it to be centered and we dimension one thing, as an example. Also, we use lots of simple features. It's easier to use simple things than hard things. Lots of simple things is simple. A few hard things is hard. So it's easier to do the model if you break it down into simpler pieces. So let's take this as an example. We have a part here, and it's a round part with this groove going down the middle, some cutouts, some holes. And we can look at this and think about what the intent of it is. And so we can see kind of right off the bat that it's got some evenness around it. Everything is kind of evenly spaced around the diameter of it. We have holes here, so these are going to be mounting holes of some kind. We have this boss here on the back that is going to go into something. We don't know if that's going to be a tight fit or more of a clearance fit. Right now, we have some kind of a groove here, maybe for a belt or something around going around it there. And then we have these cutouts here. And so we can break it into features of the main cylinder, the boss, the cutouts, and the holes, as well as the groove here. And so when we do that, if we treat each of those things as its own thing that could be changed separately, it gives us better intent. If we tried to do it all as one, now we're stuck. If we drew half this shape and we decided we want to change this boss, remove it completely, or change what this groove looks like, then we've got to go back and edit the sketches instead of just turning off a sketch and changing that. So let's take an example. I have two different approaches to this. So one is here, so finished product is the same. One starts with Revolve, then Extrude, has a chamfer, some threaded features, and another chamfer. This one uses a few more extrudes, a circular pattern, a couple chamfers, a hole, and then another pattern, and now a Revolve. And so let's take a look at what these look like in practice. So here we have this first one. And so on this one we have the full Revolve of that entire shape. So first glance, yeah, this is easy. We're get it all done. It's one step, we get it all done. But we've got a lot of stuff going on here. What if we want to change that, instead of being a circular groove to being a V groove or something like that? Now we have to go back and edit that sketch, redefine it, all that stuff. If we're on this one, where that cut is here, we can just, suppress that feature and then turn on another one that's got a different shape, or add a new feature to that. And so by having them split up, it gives us a little bit better ability to make changes. Same thing here, extruding all four of those. Bigger sketch, more going on. If we want to change the number of things in this pattern, we have to figure out how to change that. And I don't remember how to change the number of things in a pattern here in Inventor. But if I do them as features, so I do one extrude and then I do pattern that, now I can easily say I want it to be 3 of those or whatever. So it's easier to make that change. And also, I don't need to draw and manage that bigger sketch. I have a simpler sketch to work with. Same thing here. This one on the back was just a simple circle as its sketch. So simple things. Getting the chamfers, using the holes. Use the hole command rather than extruding, having to set up and create 3 circles and space them out pattern them around or whatever. It's a lot easier just to draw a single line out for the location of that hole, and then do a pattern of that. Now again, we can get how many other holes we want. So by breaking into pieces, we can get a much better usable design for this. So some general rules that I kind of made up over the years of doing this is keep your sketch simple. No more than 8 things, and usually I try and get less than 6. Break it into primitive shapes, cylinders, rectangles. If I can do a cut with just a single line or a couple lines to break it up, that's even better. Make sure you're projecting or using existing edges and things like that. Use the geometry to maintain it. So midpoints, collinear, use those geometric constraints. Use dimensions as the last step to size things that you need to size, but if you can do it with a geometric constraint by making 2 things equal, that way you don't have to put in 2 different dimensions that are the same, that's even better also. And then use the features. So they have, in all the programs, we've got the sketched features and we have the placed features, or the applied features, depending on what they call it in the program. So you can create a fillet in a sketch or as in a placed feature, but usually it's easier just to draw something square and extrude it and then add a feature on later than it is to draw the fillet into the sketch. That makes your sketch more complex. The only times when I would do that is if I'm dimensioning to the middle of those centers or to the outside tangent of a circle. But if I can draw something sharp, I'm going to do that and then just add a fillet later. Same thing with hole. Don't just extrude a circle, use the hole command. Now you have options to add chamfers, counterbores, threads, and not just to make an exact size, but make it a clearance size based on the standard. So instead of making a 1/4 inch hole for a 1/4 inch bolt to go through, you make it a normal tolerance. Now it's 0.266, so that gives that a little bit of clearance there, and it's a better product. So, all right, and that's basically the general guidelines for what is design intent and kind of how we use it in general.